Okay, we'll start. So last class we discussed about we didn't start subnetting actually, but we understood what is a problem. Okay, so what the problem is? The problem is you have a network like this. You have a router and you have a couple of switches. Let's say switch one and then switch two, and then you have only a couple of PCs, PC, PC, and PC. Okay, so the total number of devices that is required. So the total number of IPs that is required in this topology for this side is we'll have 1.1, 1.2, and 1.3. Okay, and we'll be having 2.1, 2.2, and then 2.3. Correct? So, okay, how many IPs are we are using in this network, guys? So we are using 1.0 as network can't be used. 1.255, which is broadcast, can't be used. So the remaining networks can be remaining IPs are usable IP addresses 1.1 to 1.254. Okay, so in which we have 1.1, 1.2, 1.3. Only these IPs are actually used. Okay, these are the used IP addresses you can see in the diagram, and these are the IPs that is wasted. Okay, so which means close to 251 IPs we wasted. So we discussed this in the last lesson, right? So when you just like that design network, so you are wasting so many IP addresses. There are so many wastages that we do. Okay, and in today's class, we're going to learn subnetting, which is the which will address the wastage of IP address, right? So the solution is wastage. You know, if you wanted to save some IP addresses, if you don't have to waste, then you have to understand subnetting. See, as I told you in the last class, this is the most important topic of any networking topics that you learn. Okay, this is very, very important. Okay. So yes, so last class I asked you one question. Let me open this lab. Okay, so this was the lab that I was using yesterday. Okay, I'll share the link where you can download this lab. I'll tell you. Okay, so we enter the router, we configure IP addresses like okay. So when I was trying 1.1 IP to this interface, and then when I was trying 1.129 IP address to this interface actually told it's not accepting the IP address, right? Because why? Because already we gave this IP address which belongs to 1.0 network. So when you try to give 1.129, which also belongs to the 1.0 network, the router didn't accept the IP address, right? So it just told that, you know, it's overlapping. Okay, I'll show you that one more time. Okay, what error we got in the last class. So en config. So interface FA 0/0, IP address 192.168.1.1.255.250.0. No shit. So I configured this guy, right? The first interface with IP address 1.1. Okay, now let's go with the next interface. Interface FA 0/1, IP address 192.168.1.129.255.255.250.0. And when I try to see, this is what it's saying, right? It's overlapping. Okay, when I try to give the no shit command, again, it says incorrect IP address assignment. You can see incorrect IP address assignment. Okay, so this we saw in the last system. Okay, now what we'll be doing is, guys, we're going to learn subnetting, right? After learning subnetting, right? After learning subnetting, we're going to come to the same lab. Right? The same lab I'm going to come into, and that time I'll configure 1.1 to this interface, and I'll configure 1.129 to this interface. And now the router which is throwing an error, right? After learning subnetting for next 20, 30 minutes, we'll come back to this guy and we'll configure the same IP address to the router. That time the router is gonna accept the IP. Got the point? Which means you're gonna learn subnetting and then come back to the same router, configure the same IP address. So now it's throwing an error, right? After 20 minutes, our we'll be coming back to the same router and we're gonna configure the same IP address. Now the router is gonna accept it. Okay? Yeah, let's try to understand what is subnetting now. Okay. So yes, yes. So now Let's try to understand things from scratch, please. Okay, so please listen to me. Subnetting is not a difficult topic, right? Online students, recording students, everyone, please listen to me. Okay, so subnetting is not tough. It's actually easy only, but the way you learn, that is very important, and the time that you spend is more important, right? So even if you listen to me for next 30 minutes, you will understand what subnetting is. But if you wanted to, be an expert in subnetting, you need to spend time on it, right? That is the key point. So in order to understand subnetting or in order to be a master in subnetting, you need to spend time with subnetting. Okay, yeah. So let's start first. So I have a network like this, right? Assume I have a network 192 dot. Just give me a minute. Yeah. So I have a network like 192 to 168, 1.0, 1.0. Okay. So this is the network that I have got. Now, the subnet mask is, the default mask is what? The default mask is 255 dot, 255 dot, 255 dot 0. Correct? Okay. So which means that it says that there is only one host portion, right? And that is what exactly we understand that the range of this network, right? The range of this network starts from 192 to 168, 1.0, and 1.1, 1.2, right? We're going to keep constant, right? The first three octets are going to be constant. Okay, that is what the network portion is, right? We should not change the network portion, right? And what will be the last IP address? 192.168, 1.255. Okay, how many IPs we have here? 256 IPs. Okay, now what I'm going to do is, I'm just going to write the subnet mask in binary format, guys. So this subnet mask, I'm just going to write that in binary format. So yesterday we discussed, binary to decimal, those things and all, right? When I try to convert this binary, when I try to convert this decimal into binary, I'm gonna get 8 ones. Okay, because when you convert 255 into binary, you're gonna get 8 ones, right? And here also again, it's going to be 8 ones. Again, it's going to be 8 ones in the third octet also, right? And finally here, if you see, it's going to be what? It's going to be 8 zeros. Okay. So how many ones we have here? We have totally 24 ones, correct? So 24 ones we have. So that is why we call this as what? We call this as slash 24. For what reason? Right? We call this mask as slash 24. What is the reason for slash 24? Because it has got 24 ones, right? Yeah. So now good. Let's understand this. Now I have got 24 ones in my subnet mask and then 8 zeros in my subnet mask. Now what I'm going to do is, guys, listen to me. This is where it's going to be very, you need to be, clearly understand this. So please pay attention here and listen to me. I'm just gonna leave the first 24 ones, right? The first 24 bits I'm not gonna touch, right? I'm just gonna leave them the same way. And what I'm gonna do is, so in this portion, right, where I have 8 zeros, here what I'm gonna do is I'm just gonna go and add 1 1. I'm just gonna change the first bit, right? So in where the zero starts, the zero is starting from here, no? The first zero I'm starting, the first zero that no, this guy, I'm just gonna change the 0 to 1, and I'm gonna follow that with the remaining zeros, right? Which means only one bit I've changed. Okay, this is the only bit that I've changed. One has been changed, sorry, zero has been changed to one and followed by 7 zeros I've got. Okay, now what is the new subnet mask I've got, guys? Did I do any change in the first octet? No. So 8 ones, what is it? It's going to be 255. Okay, so please listen to me. Don't get any confusion right now. Don't think of anything else. Let me finish. I'm just going to take some 20 minutes to complete this. Then you can think about it. Okay, so 255 dot 255 dot 255 dot, right? What is this case? So initially it was 0 because it was 7 zeros, so 8 zeros. Now it is 1 followed by 7 zeros, right? What is the value of this? Yeah, so we already understood in the last lesson itself, it's going to be 128, right? So it's 2 power 7, it's going to be 128. So it's going to be 128 here. So this is the old mask. The old mask, I can say old mask, or I can say the default mask. The default mask is this guy. What is the new mask? The new mask is this guy. Okay, this is the new mask. Okay, now always understand one thing is this is important. So whenever the mask has been increased, again, this is a key point. This is kind of mantra for subnetting. Okay, understand this. So whenever there is an increase, there is an increase in the subnet mask, increase in the mask, mask, right? Increase in the subnet. There is an increase, no? Here you have 0. Here you have what? Here you have 128. So whenever there is an increase in the subnet mask, right? So it results in division of networks. Okay. So maybe confusing for you guys, for a few of you guys right now. Please wait. Please wait for 10 more minutes. You will understand. So whenever there is an increase in subnet mask, right? The network is divided, right? I'll write like that, no? The network is divided. It divides the network. Divides the network. Okay. Not able to understand anything? Please wait. You will understand in few minutes. Okay. So what did I say? This is the original mask. Okay. This is the default mask. And what is this? This is the new subnet mask. Okay. And do we have any increase in the mask? Yes. Here you have 0, but here you have 128. So there is an increase in the subnet mask. So whenever there is an increase in the subnet mask, it results in division of network, or it divides the network. Okay. Now let's understand this thing. So there is a formula. The formula is to find out the number of divided networks. To identify the number of divided networks, we have a formula. The formula is 2 to the power of changed bits. 2 to the power of changed bits. Okay, so please keep listening to me. Okay, so now number of divided networks, right? So we know that whenever the mask is increased, we know the network is divided. But how many networks we're gonna have? How many networks? So that we don't know, right? So simply this says if there is an increase in the increase in the mask, it divides network. But how many divisions we're gonna have? Right? That can be identified with this formula. Number of divided networks. Now, how many number of networks is gonna get divided into? That can be identified with the formula 2 power changed bits. Okay. Now, how many bits got changed bits? If you see the total mask, right here, we didn't do any change here, no changes here, no changes. We just made only one change. You know, what is that one change? This guy. This is the only bit that we changed. So how many bits got changed? 2 power 1. Okay, so one bit changed. So the answer is 2 power 1. So what is the answer for this? 2 power 1 is 2 networks. Got it? So which means what I understand is with this, with this mask, it was one network. Initially, it was one network, right? With this mask, it's going to be two networks. That is what I understand. That is what my formula says. It's two networks. Okay. Let me take a different slide to explain this further. It seems confusing initially, but once you start doing it, you will get a very good clarity on it. Okay. So keep listening. Yes, please. So now, so with this mask, 255 dot, 255 dot, 255 dot, 0, right? How many networks we have? Just one network, right? What is that one network? The network was starting from 192.168.191.168, 1.0, right? And what is the last IP address in the network? 192.168, 1.255. Okay. Yes. So we had one network, and how many IPs we have in that one network is 256 IPs. Agree? Yeah. So this is the default one. This we know already. Okay. Now the subnetted one. What is the mask? The mask, the new mask is what? 255 dot, 255 dot, 255 dot, 250 dot 128. Okay. So here it is 0, which means we have 8 zeros here. Here it is 128. So 1 followed by 7 zeros here. Okay, is it 7? Yeah, 7. So now how many bits got changed, guys? Here 0, right? Only one bit, right? So yeah, so what did we understand from the formula from the previous slide? So 2 power changed bits. It's going to be 2 power 1, which is nothing but 2 networks again. Okay. Yeah. So now here we have 192 dot. So now we're going to have two networks here. Understand? The same one network. Now it's going to get divided into two networks. Okay, let me write the range again. So 192.168.1.0. The last is what? 192.168.1.255. Okay, yes. So now this is the range. And now this is one network, right? This is one network. But what we're going to do? We're going to divide this into two, right? So let me draw a simple line here. Okay, how many number of IPs totally we have here, please? So here we're gonna get two networks. That is what we are trying to understand. Here we're gonna get two networks. So totally, how many IPs we have totally? We have totally 256 IPs. Right? Single, if it is one network, it's 256 IPs. Now, if I divide them into two, right? How many we're gonna have here? 128 IPs, correct? Because 256 half is what? 128. And here how many we're gonna have? 128. So here we're gonna have 120 IPs. Here also we're gonna have 128 IPs. Okay. So now, yeah, try to understand. This is going to be network number 1. Okay. And this is going to be network number 2. Yeah, understand? So you're getting it right. So 255, 255, 255 dot 128. So this is the mask I'm using. If I use that mask, I'm gonna get how many networks? I'm gonna get 2 networks. So what those 2 networks will be? This is network number 1, this is network number 2. Yeah, fine. So now let's try to understand the last IP address of network number 1. Till where network number 1 will go. Okay, because we are dividing that into 2 halves. So network number 1, it's gonna get over where? Yeah, can anyone answer in the chat, please? 1 into 168 1 dot. What is the answer? So we're gonna have 120 IPs over here. Okay, what will be the last IP address? Yes, good. 1.127. Okay, 1.27 because counting from 1.0 to 1.127. So here only we have 120 IPs. Okay, yes. Now we're gonna have what is the next network number 2 starts from where? Network number 2 starts from 1 into 168, 1.128. Okay, 1 into 168, 1.128. Yeah, so now we're gonna have this as network number 1, which starts from 1.0 to 1.128, and we're gonna have network number 2, which is gonna start from 1.120 to 1.255. Okay. So now I always use this word, guys. I always use this word in my classes. Combination. Combination. So which is gonna be the number of networks and number of IPs. So what is the combination right now? We have 2 networks, right? And how many IPs we have in each network? 2 networks into how many IPs? 128 IPs. So 2 networks, and each network will have 128 IPs. Okay, so this is a combination which we're gonna this is important to learn subnetting. So the combination is 2 networks into 128 IPs. Whereas before subnetting, what is the combination that we have here? What is the combination that we have here? Here the combination is what? It is 1 network into 256 IPs. Got the point? Yeah, it's 1 network into 256 IPs over here because there is no subnetting, there is no division. And this is the mask that we were using. When I am trying to use this mask 255, 255, 255.128, we're going to get 2 networks and we're going to break them into 2 networks. So you're going to have 128 IPs and 128 IPs in both networks. So the combination is 2 networks and each network will have how many IPs? 128 IPs. This 128 is what I have wrote here. Okay. Yes, good. So now let's try to understand one more table. Okay. And please understand, take it seriously. Tomorrow we're gonna take break, right? So tomorrow we don't have class. So we'll be meeting again on Monday. So we're gonna have you guys gonna have 1 day break. So please, I know it's Sunday. You guys are not in a mood to study, but at least maybe tomorrow or before you come for the next class, right? Please practice this and come, right? Whatever I'm telling in today's class, you guys definitely need to practice it. If you're coming directly, again I'm telling you, if you guys are coming directly for Monday's class without practicing today's class because you have a break in between, please practice it. Right, take a note, whatever I'm writing, right? Because submitting is full of exercises. The more and more you work on it, the more and more you write in papers, the more and more you understand things clearly, right? It's very important. So again, I'm telling you, if you are not understanding Monday's class, that is because you have not done, you have not worked on today's class, right? Recording students also, it's the same thing, right? I know recording audience are, just increasing nowadays. People are going and watching recordings. Recording students also, I'm telling you, don't keep watching the videos next, right? Please, after you watch this video, please do the do the practices, practice it, take a note, write all the submitting exercises, and then go for next video. Okay, if you're coming directly, then I cannot help you guys. You will not understand the submitting there. Okay, so let's try to understand this in another table, right? So we're gonna call this as a subnet table. We're gonna write a subnet table. I just call them as a subnet table. Okay, what we're gonna have in the subnet table? We're gonna have the network address. We're gonna have the host, and we're gonna have the broadcast address. Just a table. Okay. Yes. So what is the mask is? What is the subnet mask? The subnet mask is 255 dot 255 dot 255 dot 128. This is the mask, right? Okay. Now what is the combination? The combination is going to be, I'll just put it like comb. It's not comb, it's combination. 2 networks into 128. IPs. Okay, good. Okay. Yes. So now here we have network number one, and we're gonna have network number two. Okay, we're just gonna write this now horizontally. Yes. What is network number? Network number one is this, right? Where it starts from? It starts from 1.0. It ends at 1.127, right? Okay, let me write that here. So network number network number one starts with 1.0 and ends at 1.127. Okay, what is the host IP? The host IP is 1.1 to 1.126. You got the point? What is host? Host means the in-between IPs, right? Which means this is what we call as available IPs, right? These guys are available. The network, you can't use it because it's network address. Broadcast, you can't use it. That's a broadcast address that is reserved. Again, we're going to have this IP address as the host IP, which is 1.1 to 1.126. Clear? Yeah. So yes, now let's go to next network. So we just wrote the first line, network number one. Hope you guys are getting it. 1.0, 1.1, first and last. This is in between IPs. Okay, good. Now let's go and try to understand what is going to be the network number two. So this is network number two. So let's try to understand that. 1.128 starting 1.255. Okay. Yeah. So now what is the host IP? 1.129 to 1.12, sorry, 1.254. Okay. Yes. So 1.0 and then 1.128. So these are the two networks that we have got. And this is the two networks, right? This is the range of IP addresses we have in that network. Very good. Now say guys, now tell me, if I use this mask, if I use this 255.258.128 mask, right? What about 1.1 and 1.129? Are they going to be in the same network or different network? If I'm using this mask, they're going to be in a different network, right? 1.1 will be in network number one. 1.129 will be in network number two, right? Now let's go back to the same topology where we had initially, we had a problem. Here was trying to do that configuration. 1.1, 1.129. But why was the router showing that error? Because what was the mask I was using there? You see here, the mask I was using there was what? I was using this mask 258.258.258.0, right? Since I was using that mask, these two IP addresses, right? 1.1 and 1.129, right? With this mask is, with this mask, 255.255.255.0. With this mask, they are in the same network. But if I use this mask, 255.255.255.128, then are they going to be in the same network? No, right? 1.1 will be in one network, 1.129 will be in another network. Okay. Yes. So now let's go and use the configuration, but this time I'm going to use this mask in the router. Okay, let's go back to the same router which was throwing the error. Okay, so I'll go to router 0, en conflict, interface FA0/0, IP address 192.168.1.1, 255.255.255 dot what? 128, right? That is very important. 128. You have to change the mask to 128, right? Again, I don't have no shut because the interface already it is a no shut state. I already gave it. I already gave previous itself. I gave no shut. You don't have to give no shut every time, please. So only once you give no shut. So already given, then it is already in green only. Now you can see already the interface is in green. You see the actual diagram here. Yeah, can you see this guy is already green? So no need for no shut again and again. Every time don't configure no shut. Okay, once no shut is fine, done, then it is fine. You don't have to configure it again. I'm just giving except, but this time I'm going to go to the other interface 0/1. Okay, and I'll just give IP address 192.168.1.129. Yeah, this is what last time it was throwing an error when we were configuring it. But this time I'm going to use what mask? I'm going to use this mask. Okay, 255.255.255.128. Sorry, 128. Okay, so I'm just going to use the same mask 255.255.255.128. And now I'm saying that I just give enter. Now can you see there is no error, nothing, right? And since this interface was not in no shut state earlier, I'm just going to give no shut now only. Okay, when I give no shut, see it's accepting the IP address, the interface status came up. Okay, so hope you guys understood what is happening. Now we gave 1.129 to this interface with this mask. So what was the mask I was using on both interfaces? The common mask. This mask I was using on this side, the same mask I was using on this side also. right? Okay, now what do we do? So now we'll just go and configure the PCs, guys. We'll just try to configure the PCs. Okay, so we're gonna have what IP address we can give to the PC. So 1.1, no. Next is 1.2, 1.3. What is going to be the gateway for them? 1.1. Good. That's the gateway because that is what the router's IP address, correct? Okay, here we're gonna have what we get. We're gonna have 1.129 is the gateway IP, right? So here if you see 1.128 is the network address. We're gonna have 1.129. This is the first IP, which already we gave to the gateway of the second interface. Okay, now what is the next available IP? 1.130. Yeah, 1.130 here 1.131. Okay, and what is the gateway? The gateway is going to be 1.129. Clear? Yes, perfect. So we have 1.2, 1.3. The gateway is 1.1. Here we have 1.130, 1.131. The gateway is 1.129. Right? Let me just go and configure the PCs also. Okay, while you do this lab, please refer the recordings and do it, guys, if you stuck somewhere in between. Okay, 1.2 is the IP address. I'm just going to configure. And when I give a tab key or when I just click on the submit mask, it is pulling me 255.255.255.0, right? Here also I need to change what? Here also I need to change. It is 128. Because why? Because even the PCs need to know that the submitting is happening, right? See, in all the cases, here you configure IP, here you configure IP, here, wherever you configure IP address in this lab, what is going to be the mask that we have to use? 255.255.255.128. It doesn't matter whether it's a router interface or PC's IP address, nothing matter, right? Wherever you in this lab, the common mask that we're going to use is what? 255.255.255.128. Okay. Yes. So now let's go and configure the gateway 192.168.1.1. Okay, good. Let's close this. Close this. Okay, we'll go to this PC. 192.168.1.3. 1.2 is already configured. 1.3, 128, 192.168, 1.1. Okay. Yes. Let's close this and go to the next piece. This time configure this piece. We configure these two guys. Okay. Yes. So let me check again. Yeah. So everything is configured. Now let's go to this PC. This PC2. It's the third PC here. This guy. Okay. So what I did, you wanted to configure him. 192.168.1.130. 129 is already configured. Again, mask 128, gateway 1.1. Sorry, not 1.129. Okay, so please be careful, please. Next is we go to the PC. 190, sorry, 192.168.1.131. Change the mask to 128, and then 191.168, 1.130, sorry, 129. Yeah, that's the gateway. Very good, cool. So everything has been configured. Now, just wanted to ping and check whether they are reachable or not. Okay, so here I'm going to take this PC and I'm going to send a ping request to 1.130. Okay, let's take ping 192.168, 1.130. We'll try to ping the PC. We'll see whether it's working or not. Okay, sure, it's working, cool. So let me ping again and see. Now it's working, right? All 4 packets, it's working. Very good. Yes, so now understand why we did this. Earlier, when we had a lab like this, right? Initially, how we had this, initially we had, let me take another slide just to explain this. Just to compare, I'm saying, what is the advantage of doing the submitting? Earlier, we had how many IPs in this side, please? We had 256 IPs on this side. Before submitting, I'm saying, before submitting, we had 256 IPs on this side, and we had 256 IPs on this side, correct? And how many IPs were used? Which is out of this 256, 254 is usable, but we used only how much? Only 3. Here also the same case, no? 254, we used 23. That was before, right? What I'm talking about before is before submitting. So here we have initially we had like this, no? 0/0/0/1. We used to configure which way? 1.1, 1.2, 1.3. Here we have 2.1, 2.2, 2.3. This is what we know traditionally before submitting. Now what we are understanding, we are, in this case, we wasted how many IPs? Totally 256 on this side. Network and broadcast cannot be used. So 256 minus 2, network and broadcast minus 1. If you see 254 usable IP addresses, in which only 3 IP addresses we used. How many wasted? 251 wasted. But here also wastage is there, please. Here also wastage is there. Here also wastage is there. But how many number of IPs we have in this network right now? It's not 256. Because why? Because the combination is what? We're just gonna have only 128 IPs in one side. So earlier we were using 1.0 on this side and 2.0 on this side. But now what we are doing? We are breaking 1.0, and the first half we are using here and the second half we are using here, which means we are saving IP addresses now. Just see, now if you have 128 IPs available on this network, how many are usable? First and last cannot be used. 126 is usable. Now how many are actually used? 3. But still wastage is there. Still wastage is there. But can you understand, guys? The wastage has been minimized. Earlier, here, how many APs were wasted? 251 were wasted. But here, 126 minus 3. Here, 123 IPs only wasted. Again, the further more and more you do subnetting, the more and more IP address wastage you can reduce, right? The IP address wastage can reduce, right? We just started with subnetting. Now itself, I reduced half of the wastage, right? I just removed half of the wastage. So further understanding subnetting, you can precisely design a network and you can avoid the wastage as much as possible. Okay. So yes, so we just started with this first subnetting, which is breaking into two networks and using it over there. Right? So here it's a wrong design because we have more IP wastage. This is a right design because we have reduced the IP address wastage. Clear? Okay. So definitely do this lab. And where do I find this lab, right? I've already told you in the previous class. Maybe if you guys, you know, didn't notice it, or maybe if you're joining new, then you can download from here ctlab.zip. Okay, this is a URL. Recording students, please check this URL. Online students, I'll just put in the chat right now. Okay, so that's the link. You can download the zip file and extract it. And once you download the zip file and extract it, you'll be able to see a folder like this, CPT lab. If you get into this lab, there are multiple documents, all these things and all. So just get into the labs. And then already static routing, we did this already. You remember, I think. Now this is the second one that we are doing, right? This is the file I was actually opening right now, right? I don't want you guys to design lab like this by yourself. Don't design it like this. What you can do, you can take my lab, which is already designed. It is already there, right? When you open this, you're going to have router, PC, switches, everything are there. Just go and configure this lab, right? Like how I was configuring. Watch the recordings also. Refer the recordings before you configure the lab. When I was configuring this lab, how I was configuring, please do that by watching the recordings. Okay. Yes. So got it. So where you can download the link, you can download the link from. You can download the file from this link. Okay, networking.in/cptlab.zip. Okay, good. Now let's get into the next thing. Okay. Yes. So just one question before you guys, before starting the next submitting, right? Honestly, answer me, guys. How many of you really got it, right? So I'm just going to create a poll right now. Please answer in the poll so that we can know how many of you really understood what is happening here. Submitting seems to be a tough topic. Again, I told you, if it's tough, then you guys have to, you should not leave it, right? You have to keep trying it. Okay, so let me just give you the poll. Please answer it. Okay, so you can answer in the poll, guys. No need to answer in the chat. Just reading the question. Okay, the question is going to come to you right now. It's a poll. So it's going to, yeah, so you can see the question right now. Please try to answer it. Okay, so please try to answer in the chat. I mean, sorry, not in the chat, in the poll. because tracking in the chat is actually tough case. So if you answer in the poll, I can know the percentage very well. Yeah, please everyone participate. Yes, so I'm just gonna end the poll right now. Okay, so now I'll share the results. Actually, it's quite interesting. Okay, I'm just gonna end the poll. Yeah, so uh, 82% you guys got it, and the 13% it's confusing. Maybe they got it, but bit confusing. Uh, Again, 5% they didn't get it actually. See, this 82% good. Maybe this 13 and then 5, please check the recording thing. That is what I can say. Okay. So some people, it may take a couple of times to understand. Hey, please watch the recording. You will get it definitely. Right. But don't skip submitting. If you skip submitting, don't try to have a career in networking, or don't try to have a career in cloud computing, virtualization, whatever it is, right? So networking is backbone for everything, guys. Networking is the backbone. So try to understand submitting very well. It is very important to design networks. Either you design networks in your organization or in the cloud or in a virtual environment. Subnetting is important. Networking is important. Okay. So let me end the poll and then let's continue with the next one. Okay. Yes. So now next thing is like, of course, now you guys can easily understand. And now all we are trying to do is we just divided into two networks, right? We did that, we understood it, very good. And usually, guys, I'm telling you, usually in my class, what I do is, since it's a live class or it's offline training or online training, whatever it is, after I do this, after I do submitting two networks, I'll ask my students to do it, right? I'll give them some 30 minutes of time. Right? I'll ask them to copy down these notes and all, right? And once they copy, once they note down, I'll ask them to do the labs, right? 30 minutes we'll spend with them, and then only I'll start four networks. Again, the nature of this training, right? We cannot do that here. So we're going to have four networks directly, but please understand your responsibility. Practice two networks, take the notes by watching the recordings, and then come for four networks, right? So you can listen to me, but when you practice four networks, please do two networks and then do four networks, right? And writing works are going to be a lot when you do subnetting, right? So you wanted to copy all these things. Now you guys cannot copy, I understand, but once you do the, once you sit for learning submitting, copy everything. Maybe particularly this particular table, right? Submit table is going to be important. This is what we're going to write, right? So my students and all, they'll be writing 30, 40 pages just for submitting alone. Right? That much amount of writing work I give to them. Okay. Yes, let's come to core networks. So now it's kind of easy only, not if you understood two networks, then four networks not will be that. Okay, so what do we do for core networks? Okay, so now from here, we're gonna just break and write the table alone, no labs, right? So no labs for core networks and all, because it's gonna be, it's gonna be difficult, or maybe we don't have time to cover all the labs over here. So no labs for core networks or any of the upcoming submitting exercises. Okay, we just go and understand it, theoretically write the table in the paper. That's it. Okay, so now how many bits have to be changed, guys? Because when you change two bits, two power two, you're gonna get four networks, correct? Okay, how many bits have to be changed? Two bits have to be changed. Two bits means where you need to change this bit also, correct? So already we changed one bit. This is the first bit. Now we're gonna change one more bit. So when you change one more bit, two bits are changed. So when two bits are changed, then how many networks you will get? You will get four networks. If two bits are changed, then what is the mask? The mask is going to be what? Yeah. So this is 128 weightage of this bit, and weightage of this bit is what? 64, right? So 128 plus 64. What is the answer? The answer is 192. Okay, so the answer is going to be 192. Okay, yes. So now four networks, we're gonna have for four networks. We are writing it for four networks. The subnet mask is what? The subnet mask is going to be 255 dot 255 dot 255 dot 192. Okay, 192. Very good. Now let's understand the um, combination. What is going to be the combination, please? What is combination? Combination, yeah. Simply. Now we're going to have four networks, right? If it is four networks, then what is going to be the number of IPs? If it is two, we got 128. Now it is going to be four, then how many IPs you're going to have? 64 IPs. Clear? Yeah. So now the combination is going to be four networks and then 64 IPs. Okay, very good. So let's try to understand here. So here I have going to have that full network 1.02, 192.168.1.1.255. Yes. So we have this full network and we're going to break them. Total number of IPs we have is 256 IPs, but we're going to break them into four networks, correct? So four quarters. Okay, we're going to have 64 everywhere. Okay, so what we're going to have? We're going to have 1.0, 1.63. You got it? So 0 to 63. And then 1.64 to 1.120, 127. And 1.128 to 1.191, right? That is what this 64 is. 1.120 to 1.191. Okay, and then we're going to have 1.192 to 1.255. Good. So yes, let's write this in the table. It's very easy, now you got the idea, right? When you break into four networks, you're going to have 64 IPs. Okay. Yes. So now here we'll have the table. The table is going to have what? The table is going to have network address, host IP, and then broadcast address. Okay. So you're going to be 1.0 network address, 1.0 broadcast is 1.63. Correct? 1.0 network address, broadcast is 1.63. What is the in between IPs? Host IPs 1.1 to 1.62. Okay, good. Okay, now sorry. This is network number one. Sorry, guys. I wrote network address. This is network number one. Okay. Network number two, we'll write in different color. Network number two, 1.64 to 1.127. And host IP will be 1.65 to 1.126. Okay, so network number three, 1.128 to 1.191. 1.129 to 1.190. Okay, and then so network number 4, 1.192 to 1.255, and then 1.193 to 1.254. Got it? So what this is what the table, right? So this is for what network? This is for four networks. Can you see? Yeah, for four networks, the mask is 255, 255, 255.192. And then what is the combination? 4 into 64. And what are those four networks? These are the four networks. What are those 64 IPs? These are the 64 IPs. You got the point? Yeah. Yes. Now, see, I really don't want to do the lab on this because if I start doing the lab, it's going to be time consuming. But I'll tell you the logic. Maybe if you guys really wanted to do this lab, you guys can do it, right? In the same CPT lab folder in the labs, there is a file called Subnetting 4 network. I'll tell you the idea, right? I'm just going to go and configure the IP addresses and show you. Maybe if you guys are really interested, whoever it is, you guys can try it out. Okay. So just give me a minute. Yes, please. So now I'll just give you the logic, right? How do we design this this topology needs four networks. Yeah. So how can I use that four networks over here? So here, so these are the four networks that we got. These are the four networks. We're going to use this four network in this topology, right? Okay. How many networks we need here? We need network number one here, one network. We can use network number two here. I can use network number three here. I can use network number four here. See, it's completely your choice, guys. If you want, you can also use network number three over here, and you can use network number four over here. But it's not that you should use network number three and network number four here. It's your choice. If you want, you can use network number three here also. You can use network number four here also. Okay. Yeah, so in my design, I'm just going to go like network number 3 here and network number 4 here. So 4 networks are required. What those 4 networks are, we already have them. Right, these are the 4 networks. Okay, good. Now let's go and let's try to understand this. So 1.0, that's the network. So this is going to be network number 1 is going to be 1.0. And what is the IP address for this interface? Right? See, this is the interface number 0/0. I'll also give you the interface number. This is 0/0 interface. This is 0/1 interface. This is 1/0 interface. And this is 0/0 interface. And this is 0/1 interface. So interface numbers are given. You can write the IP address 1.1, 1.2, 1.3. Correct? So 1.0 network. Very good. And now this time, what we're going to have, this is going to be 1 point. What is the second network? What is the network address? 1.64. Okay. So this is going to be 1.64. In that case, this case is going to be 1.65, 1.66, 1.67. Okay. So next, we have network number 3 over here. So this is the network address. So you need to configure, right? This IP should be configured here. Next, network number 3, which is 1.128. We're going to have 1.128. We'll have it over here. And then here it's going to be 1.129. If the network address is 1.128, the first IP is 1.129, right? 1.129, 1.130, 1.131. Okay, here we're going to have 1.192 network address, the last network, 1.192. And we're going to have 1.193 and then 1.194. Okay. So this is what the IP address designing is, guys. And after this, you guys have to configure static routing also. In the first router, he knows this network, he knows this network, he knows this network. But you want to do the static routing. Which network he doesn't know? He doesn't know this network, no? Yeah, you need to go to the first router and say 1.128 network can be reached via what IP address? 1.194 static routing. Okay, you remember this static routing we did? No? Yeah, that is important. Static routing should be configured over here. See, I'm telling all these things because, when you watch the recordings and if you want to do this, you can do this, right? That is why I'm saying all these things. I thought of skipping this lab, but instead of doing it, let me theoretically at least explain what should be done here so that those who are interested can do the lab when they watch the recording. Okay, now what is this guy? What networks he doesn't know? He knows about this guy. He knows about this guy. These are the two networks that he knows. What he doesn't know? He doesn't know about 1.0. He doesn't know about 1.164. Sorry, 1.64. Okay. Yes. So now we'll try to configure that over here. 1.0. Okay, we can write 1.0 and then 1.64. Okay, and then what is the next to hop IP address? Next to hop IP address will be 1.193. Okay. Yes. Again, remember wherever you configure IP addresses, here, in any of these places you configure IP addresses or you do static routing, right? Wherever the mask, right? In whichever place the mask comes in, what the mask you guys should use in this lab? 255 dot, 255 dot, 255 dot, 192. Don't forget that alone. Okay. That is really important. 255 dot, 255 dot, 255 dot, 192. Okay. Very good. Right. So hope you guys understood. Yeah. So please do this definitely. Right. First lab also take notes, write in the paper, right? And this network or this subnetting also, right? Write in a paper because only when you write in a paper you'll understand. Right. I've seen so many students in front of me studying, online classes studying. The main way to learn subnetting is, or the important way to learn subnetting is, or the correct way to learn subnetting is write in papers, right? If you theoretically just see the numbers, it seems like you know it, but only when you start writing it, that is where you understand where you make mistakes. So please do write, guys. And also once you're done with the writing part, right, just go and try this lab, right? It's just free on, everything is free, all the training, everything, materials, everything is free. All I need is just students who are interested to try it out. That's it. Yeah. So now we'll go to the next one, right? Are you guys ready? Will you go to the next one? Okay, good. So yes, so now let's try to go with the so next is what? Next is we add two networks. We understood two networks. Now we understood four networks also. Wait, what is next? Next is of course it's not six. Right? In submitting, you change one bit two power one. Right? This is two power two. You got four networks. Two power three. How many networks? Next is going to be what? Sorry. Next will be eight networks. Eight networks. So now we're gonna break into eight networks. So we can simply understand. We're gonna write eight networks. I'm just gonna write everything, guys. I'm not gonna give time for you guys to note it down right now. I'll finish it everything, and I'll give the recordings also. You guys check with the recordings and then do it. Okay. So yes. So we'll go with eight networks. So most of you already got the answer, I guess. Eight networks. Okay. What is going to be the subnet mask, guys? Eight networks. 255 dot 255 dot 255 dot. And what is this? How many? Eight networks means how many changes? Three bits going to be changed. Correct. Three ones followed by five zeros. What is this? Three ones followed by five zeros. It's going to be 128 plus 64 plus 32, correct? Because this is 128, 64, 32. Okay, so what's going to be the answer? The answer is going to be 224. 224. Okay, yes. Okay, please answer in the chat, please. I'm looking into the chat also, right? Please try to answer in the chat. So yes, so 255.255.255.224. Good. So now next is what is going to be the combination. Of course, you guys can easily find out the combination right now. Combination. Okay, what is it? If you get eight networks, then 8 into 32. What is, so initially we had what? 2 into 128. Next 4 into we had 64. Now it's going to be 8 into what? 32, correct? So 8 into 32. Okay. So now let's try to understand the table. Network address, host IP, broadcast address. Okay, here network address is going to be first network number one, we'll try to understand 1.0. So how many IPs we're going to have in single network? Just 32 IPs, right? Okay, 1.0 and then 1.31. So 1.0 to 1.31, we'll have 32 IPs. Okay, what is the host IP? 1.1 to 1.30. Got it? Okay, correct. Yes. Now we'll try to write network number two. 1.0 to, yeah. So keep answering in the chat, please. It's okay, right? I'm seeing the chats. I want some kind of encouragement from your side. Yes, try to answer the chat. So sorry. Well, no, while talking, I just made a mistake here. Okay, what is going to be? It's going to be 1.31 already over, right? What it is? It is going to be 1.32. Sorry, 1.32. I make some mistakes, guys. Often, please ignore it. Okay, yeah. So 1.63. Okay, that's the broadcast address, and then 1.33 to 1.62. Okay, very good. So next, network number three, 1.64 to 1.95. That's the next to 32 IP. 1.65 to 1.94. Okay, good. Next is again network number four, 1.96 to 1.127. Okay, that is the next 32 IP. 1.97 to 1.126. Okay. See, I'm not gonna write all these networks, so I'm just gonna skip. Right, you know, network number 5 will come next. Next network number 6 will come. Network number 7 will come, and then only you will have network number 8. Correct. So totally, how many networks? 8 networks in this lab. I'm not gonna write all the networks, guys, because we don't have time. We don't have to actually do it. What I can do is I'll just directly skip in between. Right. I'm just gonna skip all the networks in between, and I'm gonna write directly what network number 8 alone. Okay. I'm skipping, and after network 4, I'm writing network 8. Because why? Because this is the last network. Okay. So always, whenever, even when you write subnetting table, write this exercise or any upcoming exercises, write what? Write the first four network, right? From network number 1 to network number 4, right? And then skip it and write the last network. Got it? So last network is what? Network number 8 in this case. Now, what is that? Okay, many people, they have a problem in finding this out. Okay, what will be the last network? Because if you sequentially writing it, then you know, right, what will come and out. But if you directly want to jump to the last network, it's actually easy only. Is how many IPs we gonna have in a network is? How many IPs in a network? 32 IPs, right? So which means you have to subtract 256. Take 256. Don't take 255. You should not take 255. That's not right. Take 256 and minus 32 from there. And then what do you get? You get 224. Okay. So to find out the last network, take 256 minus 32. Right? Don't use 255. That's wrong, right? You have to understand it. Okay, that's something that you have to self-understand. I'm saying it like 256 minus 32, you get 224. So that's going to be the last network, right? So it's going to start with 1.224, 1.224. Okay, it's going to end with what? The last IP. We all know 1.255. That is the last IP, right? 1.255. Yeah. So that's the last network starting from 1.224 to 1.255, right? And then 1.225 to 1.254. Okay. Got idea? Yes. So this is what 8 networks is. Right. Okay. Again, please note all these things. Please write all these things. Today's recordings, I'll upload as soon as the class is over. Maybe after the class is over, in 15-20 minutes, you'll be able to find the recordings in the LMS as well as in the app. Right. I believe you guys are using the app also, right? NG app, it's actually really nice resource, guys. You can watch free recordings over there and all. Okay, in NG app as well as in NG LMS, you can watch this recording. If you're already watching this recording, then you might have been watching it from either app or from the LMS only. Okay, maybe online students I'm saying, please refer NG app or NG LMS and then get it. If you didn't have the recording access, please reach me out in WhatsApp. I'll help you out. Okay. Yes. So now quickly we'll go to next exercise. Okay, so today I'm just going to discuss only class C submitting, guys, because I want you guys to practice it first very well before going to class B, because class B will be tough. If you're doing class, if you're not doing class C and coming for class B, which is the next Monday class, it's going to be tough actually. Okay, so yes, let's try to understand 16 networks, right? Again, 16 networks, very easy. What is the mask? Subnet mask is going to be 255 dot, 255 dot, 255 dot. And how many ones here? 4 ones, right? 2 power 4 is 16, right? 4 ones followed by 4 zeros. So what is the mass? 240. Okay. Initially, it might be confusing, guys. But if you sit in a place and work with the submitting for 1 hour, then you'll understand everything very clearly. Yes. And what is the combination? What is the combination? The combination is going to be, if it is 16 networks, then it's going to be 16 IPs. Okay. Here it was what? It was 8 into 32, right? Now, what is going to be? If it's going to be 16 networks into 16 IPs. Okay. Yes. So network address, host IP, broadcast address. Okay, let me write this. Network number 1.0 to 1.15. Because 16 IPs is what we are having. No, 16 IPs means 1.15 will be last IP. What is the host? The host is 1.1 to 1.14. Okay, good. Network number 2, 1.16 to 1.31. Host IP 1.17 to 1.30. Okay. We'll write network number 3. Network number 3, 1.32 to 1.47. 1.33 to 1.46. Okay, again, network number 4, 1.48 to 1.63. Host IP 1.49 to 1.62. Okay, good. So now, as I told you, we don't have to write everything. We wrote network number 1 to network number 4. Right now, we'll just go with the last network. We'll skip all these networks in between. And then we'll write the last network, which is network number what? Network number 16. Okay. Network number 16. Okay, what is it? 1.240 to 1.255. Okay, 1.241 to 1.24. Sorry, 1.254. Yeah. Yeah, good. So hope you guys got it. So this is for 16 networks, right? While you practice, watch the recordings and then do this. Okay. Next, 32. So we're just gonna write 32 and then 64 guys. With that, I'm gonna finish it. Okay, just two networks, two exercises. Please stay with me. Okay, now we're gonna have 32 networks. Okay, so 32 networks. So if you break that in 30 networks, what will be the answer? Subnet mask. What is going to be the mask? 255 dot 255 dot 255 dot. How many? 32 means 2 power 5 is 32, correct? So it means how many bits have to be increased? 5 bits followed by 3 zeros. So what is the answer? 248. Okay, 248 will be the subnet mask. Okay, and then network address, host IP. Okay, so we'll write the combination. What is the combination? Combination is going to be what case? 32 networks means how many IPs? 8 IPs. Okay, 30 networks into 8 IPs. Okay, if it's confusing, once you start doing it, you will understand, guys. Yeah, that's what I'm again, insisting you guys to do this. Practice this, write, take a paper, write this. Then you'll understand. Network address, broadcast address, host IP. Okay, so what is the network number one? Right, 1.0, 1.7. Good. Because how many IPs? Only 8 IPs in a network. Okay, now from now it's going to be easy, right? 1.8 to 1.15. Right? Let me write the host IP also. Host IP is what? 1.1 to 1.6. Okay. Here 1.9 to 1.14. Okay, this is network number 2. Okay, now let me write network number 3. 1.16 to 1.23. 1.17 to 1.22. Okay, so network number 4, 1.24 to 1.31, 1.25 to 1.30, 30. Okay, yes. So finally, again, we wrote first 4 networks. Network number 1 to 4 we wrote. Okay, we'll write network number last. What is last network? Network number 32. Okay, what is network number 32? It's going to be 1.248. It's going to be 1.248 to 1.255 and 1.249 to 1.254. Yes. Okay, so finally we are done with this also. Right, so 30 networks is also done. We're just going to go with one more network, which is 64 networks, right? This is the last exercise. Okay, so 64 networks. Yes, so 64 networks, we're going to have subnet mask, 255 dot, 255 dot, 255 dot, 64 networks. How many ones? 6 ones this time. 6 ones followed by 2 zeros, which is going to be 252. If you add this, it's going to be 252. Okay, good, cool. We'll write the network address. We'll write the host. We'll write the broadcast. Okay, we're going to write network number 1, network number 2, network number 3, network number 4, and then directly to network number 64. Okay, so what is the answer? 1.0 to 1.1, sorry, 1.0 to what? How many IPs? Sorry, combination I forgot to write. That is why I say combination is important. What is combination? 64 networks into how many IPs? 4 IPs, correct? So we're going to have only 4 IPs in a network. So 1.0 to 1.3. Okay, host IP will be 1.1 to 1.2. Okay, just see, it is 1.0, 1.1, 1.2, 1.3. So these are the 4 IPs. 1.0, 1.1, 1.2, 1.3. All the 4 IPs are now, yeah, I wrote it. Okay. Now, network number 2, 1.4, 1.5 to 1.6, 1.7. That's it. Again, 4 IPs. 1.8, 1.9, 1.10, 1.11. 1.12, 1.13, 1.14, 1.15. Good. And finally, we'll write the last network, which is 1.250 to 1.255 here, in between 1.253 to 1.254. Okay, yes, got it. Okay, so very good. So we just understood. Now, for 64 networks, what is the combination, guys? We have 4 IPs, right? Maybe if I try to break into 120 networks, if I'm, let's say, why am I stopping with 64? Why am I not going to 120 networks? If I go to 120 networks, 120 networks into how many IPs? Now only 2 IPs, no? If you have 2 IPs, one IP will be network address and the other IP will be what? Broadcast address, right? You don't have anything for host. That is why I always say stop at 64 networks. Got the point? Stop at 64, because if you break 128, you're going to have only 2 IPs. One will go for network, one will go for broadcast, and you don't have any host IP. So why should we have a network without a host IP? Because network and broadcast anyway, we can't use it, right? So only host IPs we can use it. So if there is no host for 120 networks, then why should we do it, right? So you're going to stop at 64 networks only. Okay, clear? Yes. So I want you guys to, I'm just stressing enough to please practice this. And before I finish this, one last thing, along with your exercise, you please do this also. Yes. So so finally, we'll write this table, right? See, the name that I kept for this table is subnet table, right? This is my own name. Okay, there is no official name for this. This we call it a subnet table. This is what we have wrote so far. This table is summary table. Okay, I kept a name like summary table for them. Summary table for class C. Okay. Yeah. So what is summary table for class C? Nothing, guys. So whatever we have wrote now, we're just going to summarize it. Okay. So now we'll have subnet mask. Okay. Subnet mask. And then we're going to have this slash, right? Because subnet mask can also be represented in what format? Slash format, right? Okay. Now, how many bits got changed? How many bits changed? How many bits unchanged? UCB, unchanged bits. Okay. And what is the combination? Okay. Very simple. So what is the mask that we had initially? 255 dot 255 dot 255 dot 0, correct? This is the initial mask. What is the slash notation for this? Slash 24. Okay. Did we change any bit? Did we do subnetting here? No, this is the default mask, right? We didn't do any subnetting. Can you see it is 0 only? So how many bits are changed? 0 bits are changed. 0 bits are changed. Okay, change bits is 0. How many bits are unchanged? No bits we change, right? So if you see this, if you try to convert this into binary, it's going to be what? It's going to be 8 zeros only. No bits has been changed. So all bits are unchanged. How many bits are unchanged? 8 bits are unchanged, right? So 0 bit change means 8 bits are unchanged, correct? Okay, what is the combination? The combination is going to be very simple, right? The combination is the same combination what we wrote here. This is the same combination, but I'll write in a different way. Combination, I can write it like this: 2 power changed bits. Okay, combination I'm going to write like this: 2 power changed bits into 2 power changed bits network into 2 power unchanged bits IPs. Okay, this way also you can find out ways. Number of networks, how you find out ways, how you find the networks? By number of bits changed, correct? How you find the IPs? Number of bits unchanged, right? It's simple. Okay, I'll write, you guys will understand now, right? So 2 power, how many bits changed? 2 power 0, network, correct? Okay, 2 power change bits. How many bits unchanged? 2 power 8, okay, IPs. Okay, now I'm trying to write this in the full format, which is what is 2 power 0, guys? 1 into how many IPs? 2 power 8. What is 2 power 8? 2 power 8 is 256, right? Okay. So this 2 powers and all you need to immediately understand is 2 power 8 is 256. If it's taking some couple of seconds for you to understand 2 power 8 is 256, then you need more practice, right? So you need to immediately know that 2 power 8 is nothing but 256. Okay. Yeah. So once you start seeing these numbers, you will understand it automatically. So 256 IPs. So this is a combination in 2 power format. This is a combination in the number format. Okay. I want you guys to write both. Okay, now what is next step? So next is we're gonna have what? We're gonna have it's same 258, 258, 258 dot 128. Okay, so dot 128. Sorry, 128. Okay, this 0 has been changed to 128. Now what is the slash notation? Slash 25. Can you understand why it is slash 25? Because here 8 ones, here 8 ones, here 8 ones, here only what? 1 followed by 7 zeros, correct? So slash 25. Can you understand how we got the slash 25? Okay, what is the changed bit? 1 bit changed. What is unchanged bits? 7. Okay, what is the combination? In 2 powers, 2 power 1, right? 2 power 1 networks into 2 power 7 IPs. Okay, so what is the combination? The combination is 2 networks into, because 2 power 1 is what? 2. 2 power 7 is what? 120. 2 networks into 128 IPs. Okay, cool. And now I'm not gonna write everything, guys. From now, I'm just leaving it to you guys. Right? I want you guys to write for slash 26. Okay, write this whole row for slash 26. Write for slash 27, the whole row. Slash 28. Right? And then slash 29. Write the full row. And then write it for slash 30. Okay, I want you guys to write it by yourself. When you practice the summary table for class C, right, I wrote for slash 25 and 24 and 25, right? I want you guys to try for 26, 27, 28, 29, 30. Okay, yes, guys. So with this, I'm finishing today's class. Again, I'm telling you, very important. Please practice it. That is why I know I wanted to have this submitting class on Saturday, and I wanted to give a break on Sunday, so that you guys can take some time, do it, and then join for next class. Because if you're directly joining, then there is no purpose, guys. If you're sitting in the class for 1.5 hours or 2 hours, then that 1.5 hours and 2 hours should be useful. If it should be useful, then you need to off the class. Right? Apart from online session, you need to spend some time with submitting. Only then you will understand. This topic is very important, right? So many guys will understand it very easily, because if you like mathematics, it's going to be easy. If you love mathematics, you love submitting. For people who doesn't like mathematics, for them only it's going to be a little tough, right? That to class C was easy. Okay, that you guys understood. Many felt like it's so easy and all, but class B, right, which we're gonna discuss on Monday, it's not going to be that easy, guys. Right, and class A, it's going to be even more tough. Class B, class A, it's going to be even more tough. So please practice class C very well, and then only you'll be able to kind of understand class B, and then only you can understand class A. Okay. Yes. So let me finish the session over here. The recordings will be immediately uploaded, maybe next 15-20 minutes. You can find in the LMS, or you can find in the Network Geek app. See you guys on Monday. So tomorrow we'll take break. Okay, see you guys on Monday. Thank you, guys. Thanks for joining the session. Bye.